Hello and welcome to Module 16, Network Security Fundamentals. Please don't forget to take notes and submit them when we're all done. So we will cover security threats and vulnerabilities, network attacks, network attack mitigation, and device security. So this is a quick overview of security fundamentals. Okay, so let's start. The types of threats that might be out there. So please write the following down. Information theft. So this is a big thing. This is when we're talking about data security. Data loss and manipulation. Somebody can corrupt your data by sending you a virus or a worm or a Trojan horse. Identity thefts can cost billions of dollars to individuals and to companies, of course. And disruption of service. You know, your clients may not have access to certain services, and resources because of the denial of service attacks. All right, let's take a look at the types of vulnerabilities. Write the following down. There is technological, configuration, and security policy. Technological vulnerabilities is this is from the TCP/IP protocol's weaknesses. HTTP is not secured. Your emails by default are not secured. FTP, Telnet, all that data traverses the network in clear text. That's with IPv4. IPv6, on the other hand, is a lot more secured, of course, because we've discussed that earlier. Operating system weaknesses, especially when a new operating system come out. There's a lot of security loopholes, and they have to be patched up. Network equipment weaknesses, same thing. It's either the operating system or the default settings you have to take care of. Configuration for vulnerabilities. You may have unsecured accounts, system accounts, easily guessed password, misconfigured internet services, and so on. And the security policy vulnerabilities. Not having a security policy is the biggest problem that you may run into. So you need to have a security document, and it has to be enforced. All right, the types of network, the physical security, we're talking about hardware, environmental, electrical, and maintenance. So write these down. Hardware, having an attacker having access to the physical servers, switches, very bad. Make sure that no one knows where the server room is and no one has access to it. You should not even have to go there because you can access everything remotely either through Telnet or SSH or remote desk. So there is no reason for you, unless your office is physically next to the switches and routers and the servers, which it should not be. But otherwise, you'll lock it up and make sure no one knows exactly where that is located except you and maybe a few other, higher end administrators, maybe the chief information officer. You got that includes the routers, the switches, everything that's in there. Environmental, you want to make sure that server room, for example, has HVAC, heating, ventilation, and air conditioning, because sometimes it gets too hot, sometimes it gets too cold. You got to make sure that it's the humidity is not too high, not too low, because that will attract electrostatic discharging, right? So you got to have some surveillances, cameras. This will send you an alert and say, in case something goes wrong. Electrical threats, this includes having big spikes, voltage spikes, blackouts. So you got to have the UPSs, the surge in case there is a blackouts. Maintenance threats, so poor handling of any electrical components. So you got to be very careful. The poor grounding, for example, or labeling. You don't know where everything goes. All right, so let's take a look at some of the network attacks. Viruses. Okay, I want you to write the following down. For a virus, it makes a copy of itself or becoming part of another program. It can spread as long as the user has to interact or has to do something for the virus to spread, like copying it from a USB drive from a USB flash to another PC. Worm, on the other hand, is a malware that's, write this down as well. Worm, on the other hand, is a malware that spreads throughout the network without the intervention of the user. You don't even have to do anything. You have an open port malware, a worm will come in and will start to go over and spreads itself all the way out across the internet. This is similar to what we are experiencing today. The coronavirus, COVID-19, right? I'm actually recording this on April 7th, 2020, and we are in the midst of quarantine in New Jersey because of the COVID-19. So you may think of that, that virus spread so fast, you may think of it as a worm, where no one really had to do anything. Well, actually, we had to do something, but the only way to actually get the virus, but it works like a worm. What you have to do is, because you don't have a defense for it, you have to quarantine all the machines, make sure so it doesn't spread. That's the only way to contain it. And that takes a while, and you got to clean all the machines up, and it could be a pain, and it could be very, very costly. So that's why you need to have a security policy, hopefully, that will take this into account, where worms may be able to come in. All right. Anyway, Trojan horses is another type of malware that spreads throughout the network without the intervention of the user. I'm sorry. Trojan horse is write this down, is a software that looks legitimate. They do not replicate by infecting other files, and they reproduce themselves, but they need user interaction to spread as well, just like a virus. All right, then we have reconnaissance attacks. Reconnaissance is when you are scanning the area, or scanning and trying to find out, what's vulnerable and what's not. So you may use NSLOOKUP, WHOIS command, the Nmap command, vulnerability assessment tools such as OpenVAS and Nessus. All of these are different tools that will allow you to see what's vulnerable on the network. An attacker will always use reconnaissance attacks before they actually do the access attack. The access attack, write this down, is unauthorized system access or user privileges. This includes the password attacks, trust exploitation, port redirections, and man-in-the-middle attack. Okay? And then you have the third type of attack is denial of service attacks. Denial of service attacks, write this down, is disabling or corruption of network systems or services. It's very hard to eliminate. This is the most common type of attack over the internet nowadays. The distributed denial of service attack, also write this down, is what we call a botnet. A botnet is short for robot network. A botnet is many computers that are controlled by an attacker. And those computers that are controlled by an attacker are called zombies. All right, so when it comes to access attack, so write the following down. You got the passwords attacks, trust exploitation. We wrote that. So just to explain what these are, somebody can guess your password either using brute force or packet sniffers or Trojan horses that are sitting on your computer. Trust exploitation is when you have a threat actor that uses unauthorized privileges to gain access to the system and possibly compromising the target. Port redirections, and you got the man-in-the-middle attacks. All right. And we talked about the denial and distributed of denial of service attack as well. All right. Now we're going to take a look at the network attack mitigation. How do we mitigate against these attacks? So, the first thing you are going to do is the defense in-depth approach. So what does that mean? That means layered model. Okay, so you have to put, for example, a firewall, an IPS, and maybe the router before anything goes into the network, or vice versa. You have a VPN. The data has to go through a VPN, a virtual private network, where the data is, where data is goes in and decrypted, passed to the firewall, check it out if they're allowed to come in, and then pass it to the IPS, the intrusion prevention systems, to see if it's an attack or not before they go into the network. So, and if it needs to be authenticated, it's sent to the AAA server to be authenticated. All right, so you got a VPN, and so on. We'll discuss some of these as we go along one by one. So a VPN is to allow users to connect on the internet as if they were their own private network. A firewall, the ASA firewall, this is specifically for Cisco. The advanced security appliance. This one allows either packet to permitted or denied, depending on a list. IPS, intrusion prevention system. Has signatures of some, let's say, denial of service attacks, that if they sense this is a type of attack, they'll block it before they enter the network. Then you got the ESA, WSA, that for it has a whole bunch of different firewalls and everything in there. For it could be an IDS system in there for access, also to allow access and to do the AAA as well. And then the AAA authentication, authorization, and authentication, authorization, and accounting. So when you are remotely trying to get access, you're sent there, and then your username and password is going to be validated. Once you are validated, then you are going to be authorized to do something. And after you are authorized for certain resources, we're going to keep an account of what you did. That's what the accounting is for. All right. So number one, also to mitigate, other than doing a layered model, is you want to have backups. Backups. Extremely important. Backups of users, host systems, and of course the servers. How frequent should you back up? Where are you going to store? So write that down, so keep in mind. The storage, how are you going to secure it, right? And validate the actual data that's been backed up. That's extremely important. A lot of people back up the data, and the data that they backed up turned out to be corrupted. So periodically, you should definitely check the check the backups and make sure the authentication, and make sure also that the backups have a password. Not everyone has access to them, right? So that's for that when it comes to backup. Upgrade, update, and patch. So that is true. You always got to do this to operating systems for anything, right? Especially if you bought a new device and that device has been sitting maybe for a year, and as soon as you turn it on, it needs to get a lot of updates. So you let it go and sit and make sure all the updates is up to date for a new host, a new operating system, a router, or a switch, right? So make sure you update, upgrade, and patch whenever is needed. All right. And the AAA, like I said, this is an authenticating server. So it's not good enough just to have a username and a password. You also need to, after they've been authenticated, which means you validate the username and password that they typed in, you authorize them. You set up, for a user or a group, after they've been authenticated, they are going to be authorized to use some resources within the network. And after they've been authorized, you keep an account of what they did. You want to make sure they did not do what they're supposed to do. They did not escalate the privileges. So, in a sense, you'll be able to know if it's an attack or they did anything illegally. You know who did what. All right, I'm going to stop right here. And when we continue with the next video, we'll start with talking about firewalls and the DMZ. All right, so write up everything I asked you to write up, and I'll see you on the next video.